Today I am going to discuss all about vertical circular motion. Here the motion is confined in one dimension. So start motion in vertical circle. Here energy is conserved. I mean total energy, kinetic and potential is conserved. So before starting we should keep in mind the whole system is under Earth's gravitational field. The lowest point in the circle is considered as ground level. As the body moves upward along the circle, the potential energy changes. So, velocity changes and the motion is not uniform. So, we will draw first the picture here. Here we take a string. The length of the string is r and we tied a body of mass m here. Now we start rotating in a vertical circle. So the height of the top and bottom place of this vertical circle is 2r, and we label the bottom position as A and top position as B. Let us take an arbitrary position P. The weight of the body is along downward direction, and at position P the mass has velocity v. So the part of the weight that is radially outward is mg cos theta. Clearly the angle theta the string makes with the vertical. Now the position P is above height h from the bottom position. So the remaining height is r minus h, and the velocity at bottom is u. So clearly cos theta equals to r minus h by r. So with these tools we are going to find the velocity at position P. So we have this picture. To find velocity, we will equal the total energy at position A and at position P, because throughout this motion the energy is conserved. So at position A the body has only kinetic energy because we label this position as ground level, and at position P the body has both kinetic and potential energy, and that is half mv square plus mgh. So we get the velocity v square equals to u square minus 2gh. Now we will find tension of string. Here we are going to find tension at position P. So we have this picture. At position P we have a net resultant force, that is the tension minus the outward direction, the weight of the body, and this resultant force will supply centripetal force to keep the body moving in this vertical circle. So T minus mg cos theta equals to mv square by r, and further simplify T equals to mg cos theta plus mv square by r, and mg we replace cos theta by r minus h by r plus mv square by r, and next step we will replace v square by u square minus 2gh. So in final we get the tension m by r u square minus 3gh plus gr. This is the general expression for tension at any point throughout this vertical circle. We should keep in mind this equation. Now tension of the string at top and bottom position. So what is the picture is here, that bottom position is A and top position is B. Clearly the tension in the string in bottom position is along the point O, actually along the center, and in the top position the tension is along downward direction. Case 1, when the height is 0, I mean to say the bottom position. Here, tension at A, TA equals to m by r u square plus gr, because h equals to 0. So, in the previous case, we have the general expression that m by r u square minus 3gh plus gr. If we put h equals to 0, then this term will not remain. So, we get this expression. Now, case 2, at the top position when height is equals to 2r, we get the tension at B, m by r u square minus 3g, and we replace h by 2r plus gr equals to m by r u square minus 5gr. So clearly we see tension at position A is greater than tension at position B, and the difference of tension at top and bottom position is equals to 6 mg. I mean to say 6 times the weight of the body. Now we are looking at this picture, we will find velocity of the body at different position. So minimum velocity for looping a loop. To complete this loop, the body machine should have minimum uh, velocity u is greater than 5gr. How to loop to continue this circular motion? The body, the tension at position B must be greater equals to 0. And with this condition, we find here m by r u square minus 5gr greater equals to 0, and the u greater than 5gr. So if the body starts with u and which is equals to greater than 5gr, then it will complete the loop. Now velocity at highest point B is v equals to u square minus 2gh equals to root over 5gr minus 2g into, we replace h by 2r. So we get the velocity equals to root over gr. When the string is horizontal, I mean in this position, the velocity is u square minus 2gh, so root over 5gr minus 2gr equals to root over 3gr. So the velocity here is root over 3gr. So we get at 3 position velocity. Now we will find conservation of energy at every point. First start with position A. Here the body has kinetic energy K equals to half mv square equals to half m into 5gr, because this is the minimum velocity required for to continue the circular motion, vertical circular motion, and we get K equals to 5 by 2 mgr. And here potential energy is 0 because we label this as ground level. So total energy is 5 by 2 mgr. Now we get position B. Here the kinetic energy is half mv square equals to half mgr, and the potential energy is u equals to mgh equals to mg into 2r equals to 2 mgr. Now the total energy is kinetic and potential is half mgr plus 2 mgr equals to 5 by 2 mgr. Now conservation of energy at the middle position. We have this position. Here kinetic energy is half mv square equals to half m into 3gr equals to 3 by 2 mgr, and potential energy is mgh equals to mgr because the height is the radius of the string. Now total energy is kinetic and potential is 3 by 2 mgr plus mgr equals to 5 by 2 mgr. So thank you. If you like this video, please subscribe.